Okay, 7.3. Our goal today is talk about different periods of the sine, cosine, and tangent curve. So let's take a look at the sine and the cosine graph. How do you graph this? Y equals sine x. So let's say we don't have a graph. What would you do? On what?
Zero. Origin.
Oh, wait, what?
X-axis.
I thought it was on zero. Oh, okay, yeah, the
Now, what's this number? I'm not writing it for you, you're
Pi
telling
over
me.
two.
pi over two
Pi over 2, what are you gonna do?
One.
on one.
You're gonna
I mean,
go
above, sorry.
Above. Then what's this next number?
Pi.
3 pi.
Pi.
Yeah.
So it goes on, above,
On
then what's this number right here?
3 over two.
And those below.
Then it goes below, and then what?
2 pi is on.
2 pi. And what did you say, Robbie?
Huh?
What did you say?
What?
I thought you said we're done. What do you mean by we're done? Did you say we're done?
No.
Somebody said that. I thought I heard it. Well, we are done.
Oh, cool.
Maybe that's what I wanted to hear you say. We're done. We're done with what?
The first period.
We did one complete period. How long did it take us to go from here to here? What's this length? What's the, what is it? 2 pi. From 0 to 2 pi is one full period. So the period before this thing starts repeating itself is 2 pi. Now, what if there was a number in front here? What's this called? So if I gave you y equals 2 sine x, what did that number do?
Increase your amplitude.
Stretch
It stretched it. So instead of it's on, we would go up to 2, on, we'd go down to -2, and it would look like this, right? Now, what if you had a number outside here? What would you then do? What does this +1 do? It shifts your graph 1 unit up, and then you would go on, you'd go 2 above, like this, right? But still, the period is from 0 to 2 pi. Well, today, what you're gonna look at is this number right in front of x. It's called your b value. What's going to make your period change is this b value. All along, b was 1. All along, up till now, b was 1. If b is 1, if it's 1x, it's going to take 0 to 2 pi for your period to complete. If it's a tangent graph or cotangent, it's 1 full period. But we need 2 full periods to get from 0 to get the complete cycle for sine and cosine. So now you're going to see when the graph has a number here that's not a 1. So let's take a look at what you do. Okay, so here's an example. It says sine 2x. This is your b value right here. That's your b value. So the amplitude on this is a 1, because it says y equals 1 sine, yeah, you have this, right?
It's at the bottom.
At the bottom? At the very bottom. 1 sine 2x, and then there is no phase shift, no vertical shift. So for this one, the amplitude is 1, and the vertical shift is 0. That's that. Now these are the 2 new things that we're going to talk about. The period, if this were a 1x, it would be 2 pi. But what you're going to do is you're going to do 2 pi, and you're going to divide it by the b value. What is this b value? That's b.
Oh.
2. So, in other words, for this particular problem, the period is pi. So you will take 2 pi and divide it by b, and you get pi. Now can you tell me, and Kelsey kind of said it, how many increments are there to get from here to the end? Let's count, how many increments? That's 1 increment. 4. There's 4 increments. Yes, there's 5 dots. 1, 2, 3, 4, 5. There are 5 dots, but there's 4 increments. So think of this as an increment, this is an increment, this is an increment, this is an increment. There's 4 increments. So to get the entire cycle complete for sine and cosine, there are 4 increments. So to figure out what the increments are, you're going to take this period and you're going to divide it by 4. So in other words, what's happening is this graph is going to complete the cycle by pi, but the increments are pi over 4. So look at this right here. This is our first graph that we did. Here's 0 to pi. What would happen is this thing has to complete the cycle. It has to go like this. On, above, on, below, on. It has to complete the cycle from 0 to pi. It has to do the 4 increments within 0 to pi. So 1, 2. So in other words, what are each of these increments? They are pi over 4. So you're going to count by pi over 4. Pi over 4. So here's your graph. You have pi over 4 here, 2 pi over 4, 3 pi over 4, and 4 pi over 4. That's 1 full period. Now we can go the other way. Negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, and negative 4 pi over 4, which is pi. So now we are going to, you have to imagine that I changed my scale, but technically, if you were to put it on the regular graph, this cycle is happening real quick. So instead of it going on at pi over 2, it's on at 0, and then instead of going above at pi over 2, it's going at pi over 4. So it's happening quicker. So this is the cycle. Here it is. You're going to go, now you're going to graph the sine curve with an amplitude of 1. So you're going to go on, above, on, below, and on. Just like that. And then it says in the directions, graph 2 full periods. Okay? So, this is what you have to remember for sine and cosine. You will take, we're going to do next example. The amplitude on this one is 1. 1 is your amplitude. This is what you have to remember. The period for sine and cosine is 2 pi over b. What is the b value? So why is it defined as 2 pi? Because that's what a regular sine and cosine it takes for it to complete the cycle. So 2 pi over b is 2 pi over a half, because a half is, this is the b value. That's your b value. That's b. When I talk about b, it's the number in front of t or x. Now, you're going to leave this as 2 pi over 1/2. Can you simplify this?
Yeah.
What is it? 4 pi. So now, for this particular problem, it has to complete the cycle from 0 to 4 pi. So in other words, here's our original graph. It's going to start on, and it would go to pi. That would be your first jump. So it would go from here, and then it would come back down to 2 pi. So it's taking this would be 3 pi, and then 4 pi. This would be 3 pi, and this would be 4 pi. So it's going to take from 0 to 4 pi for this thing to go on, above, on, below, on. Okay? So 4 pi is going to take us to get to the very end. Now, how do you do the increments? How am I going to number my graph? Well, you take this period and you're gonna cut it into 4 increments, because there's 4 increments for the sine and cosine graph. So that means each increment, instead of it being pi over 2, it's pi. So this is how you're gonna count. You're gonna make this pi. This is gonna be 2 pi, 3 pi, and then 4 pi. And then this would be negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Now, is there a vertical shift on this one? Is there a shift up or down? No, so write nothing. So how would you graph this now? What does the cosine graph look like? And now, remember, it's a -1 here. So what are you gonna do? Where are you gonna start? Good job. Start down 1. And you're gonna go, so you're gonna start below, on, above, on, below.
Does that mean the amplitude is variable?
The amplitude is 1.
Oh.
This is a reflection over the x-axis. Okay? How's that? Next one, same thing. Okay, tell me what the amplitude is.
3.
Good, 3. Tell me what the vertical shift is.
2.
So those are 2 easy ones. Those are old hat. Now, what's the b value?
4.
4. B is 4. So it's a sine, so you're gonna do 2 pi over b, which is 4, which is pi over 2, simplify it. So we've gotta complete the whole cycle within pi over 2. We gotta go on, above, on, below, all by the time you reach pi over 2. So what will our increments be? You're gonna take this and cut it in, cut it into 4. Take your period and cut it into 4 sections. So in other words, they're pi over 8 increments. So you're gonna count by pi over 8. So here we go. So you're gonna rename this as, this is 1 pi over 8, this is 2 pi over 8, 3 pi over 8, and 4 pi over 8. And by the way, what is another name for 4? Watch the cord, you don't trip. What's another name for 4 pi over 8? What's another name for 4 pi over 8? And isn't that's our increment right there, or that's our period? Don't trip.
No.
Okay, and now we're gonna go the other way. -1 pi over 8, -2 pi over 8, -3 pi over 8, and -4 pi over 8. Okay, anyone think they know what to do next?
Yeah.
Up to, I heard it, up to. What else? On, above 3, on, below on. Go the other way. Do you get this? Anybody lost? So really, if you were to take this graph and squish it here on this one, this thing has to end at pi over, it has to finish the cycle at pi over 2. There's pi over 2. This thing would have to go on, above, a whole 4 cycles, or four increments, I should say, have to be between here and here. Okay? Okay, next one. So what you're actually doing, you're horizontally compressing your graph, or you're stretching it. depending on what B is. If B is greater than 1, it's a horizontal compression. So what we did on this one, actually, we horizontally compressed it. If we were to put this on here, you would see it looking like this. Whoops, sorry, I didn't do a very good job on that. On, above, on, below, and it would be back on, like that. So the whole cycle would be between 0 and pi over 2. So if B is less than 1, you're gonna stretch it. And the one that we stretched was the one prior. That's a stretch. Because it went from 0 to 4 pi. Boy, that thing took forever to get the complete cycle, 4 pi. Now, how do you do the secant and cosecant one? See if you remember. What are you gonna graph instead? Mm-hmm. Okay, so what is the amplitude? 2. It's 2 units off the x-axis. How do you do period? 2 pi over 4, because B is 4, and it's pi over 2. Again, this is gonna be a horizontal compression. Your increments, you're gonna take your period and cut it into 4 pieces, so pi over 8. And this is gonna be a shift 1 unit down. So we're gonna count by pi over 8s again. So you have 1 pi over 8, and if you wanna skip 1 pi over 8, 2 pi over 8, 3 pi over 8, and then 4 pi over 8, I don't mind. Negative pi, because it's hard to squish that all in. Negative 1 pi over 8, negative 2 pi over 8, negative 3 pi over 8, and then negative 4 pi over 8. Okay, what do I do next? Graph the negative 1. Graph the negative 1. And is this a sine or a cosine graph?
Cosine.
Cosine, and the amplitude is 2, but it's a negative 2, so where are you gonna start?
2 low.
You're gonna start 2 down,
Yeah.
and you're gonna go below, on, above, on, below. Now, this is technically supposed to be a broken line. Why am I doing it broken?
It's not your graph.
Because it's not the graph. Okay, but I need that shadow or that broken line to do what? What do I do now? Draw in my asymptotes. Very good. Asymptotes are here, 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 and here. So what do you do at this point?
Draw the bumps.
Here's your graph. So the low point is the high point. You want to touch it. And now because it's saying 2 full periods, I got to do these half ones. Like that. So there's your graph. So what do you think? Not too bad? Easy. Okay. Now, we're going to little different thing here. Tangent. Now, let's talk about, this is an old problem. Let's graph the tangent graph. How do you graph the tangent graph? This is a regular tangent graph. How do you graph it? Where's your asymptotes at?
Pi over 2.
Pi over 2. Right? Like this. And the steepness of this, we don't call this amplitude. This 1 is called your steepness. So this thing looked like this. Like that. And I have a question for you. That's 1 full period. How long did it take us to get from 1 full period? What's the length of this time right here? Is it 2 pi? How long did it take me to go from here to here? What's this length right here? It's pi. So the period for tangent is every pi. Now, how many increments did it take for me to get to the end? This is one increment, that's another increment. So you're gonna take your period now for these ones and divide them by 2. And this does not have a vertical shift. So now, how are you gonna do this 2 tan? Well, again, the steepness is 1. Your period is gonna be pi now divided by b. So pi over b is 2. So now we're gonna do this whole cycle within a half a pi, not a whole pi. Your increments, you gotta cut this in half because there's 2 increments for tangent. So pi over 4. There's no vertical shift here. So now we're gonna count by pi over 4. So think of this as pi over 4, and this is negative 1 pi over 4. So these are your increments now. And again, it's a steepness of 1, so it looks like that. So basically, what you've done is you've done this problem quicker. It's going to be compressed again, horizontally.
Can you go back to the little
Box, yeah. You get it?
Yeah.
Okay, do 2 more, and then one equation.
Where's the graph?
Wait.
The last one.
The last one?
If it's pi over 2, don't you have to graph it?
Say it again?
Don't you have to graph it 2 pi over 2?
Yeah, you mean do another period?
Yeah.
Yeah, you should. So this is 1 pi over 4, 2 pi, this would be 3 pi over 4. Yeah, you should do another period. So yeah. That's 2 full periods. Okay? So your increments are what you're counting by. Let's do 2 more graphs. Okay, what's the steepness on this one? 2. Your period, you're gonna take pi and divide it by 3. Is that your b value? This is b. Now, how long does it take to complete the cycle? How many increments are there? There's 2. So this thing is gonna go by 6s, 1/6. And by the way, 1/6 is 30 degrees. So we have a shift 1 unit up. So we're gonna count by pi over 6. So this is gonna be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This would be negative pi over 6, negative 2 pi over 6, and so forth. Where are your asymptotes? Here. This is a shift 1 unit up. And a steepness of what? So you're gonna go 2 up and 2 down. So this is 1 period right here, and I can do this one right here too. So at 3 pi over 6, you're gonna have another asymptote. Questions? Okay, one more graph. Cotangent. What's the steepness on this one? Not, you don't say -1, it's just 1. There's, steepness is it's a positive, it's like, how long is this room? You wouldn't say -1, it's always a positive number. Your period, you're gonna take pi, and you're gonna divide it by 1/2. What's pi over 1/2? 2 pi. Now cut this in 2. What's 2 pi over 2? Pi. So we're gonna count by pies. We're counting by pies, so this is 1 pi, 2 pi, 3 pi, 4 pi, -1 pi, -2 pi, -3 pi. I have way more than I need. Now, where were your asymptotes for cotangent? Would I put them here at -pi and pi? Where were the asymptotes when we did these cotangent ones? Where should I put the asymptotes here?
0 and pi.
At 0 right here, and where? And at 2 pi, and at 4 pi, and at -2 pi, and at -4 pi. Now, this is a shift 3 units up, so we would have your new x-axis here. And now, it's a negative cotangent. If it were a regular cotangent, it'd be going this way, but what does a negative cotangent look like?
Goes to the-
Like a tangent.
Like a tangent, so it looks like this.
Oh,
That's 1 period, that's 2 periods, here's 3, I just did 4 for you. And by the way, this was up 3. Okay? Last question. Yes, Roddy, go ahead.
On the last one,
Uh-huh.
if the period is pi over 3, why did we graph up to 3 pi over 6?
3 pi over 6. Because it says 2 full periods. The directions are 2 full periods. So you could do pi over 6, 2 pi over 6, 3 pi over 6. And negative, I did from negative pi over 6 to 3 pi over 6. It's 2 full periods. Ignore this.
Okay.
You get it?
Yeah.
That's 2 full periods. Okay, last thing. You will have one of these questions for sure. I'm going to give you some information. Write an equation for the sine function. It has an amplitude of 1/2. The period is pi over 2, and it's a shift 3 units down. So what are you gonna do? We need to find, we know what A is. We know what D is. We have to figure out what B is. So if it's a sine equation, sine is 2 pi over B. So if the period, if we're saying that the period is pi over 2, how are you gonna solve for B? Cross multiply. You're gonna do pi B equals 4 pi. These pi's cancel, and what's B? B is 4. So if it's a sine or a cosine equation, you will set 2 pi over B equal to whatever the period is and solve for B. If it's a tangent or cotangent, for tan or cotan, to find the B value, you do pi over B, and you set that to the period. So if it's tangent, sine or cosine, it's 2 pi over B. If it's tangent or cotangent, it's pi over B. So B is 4. So what would this equation be? F of t equals 1/2 sine 4t, minus 3, because it's 3 down. That concludes our notes. And here's your homework.